de la tarde. Pero va a ser de una manera experimental e innovadora, como les había contado, porque si esta mañana hemos hablado de estrategias, hemos hablado también de posiciones, operaciones globales, escenarios globales, ahora por este escenario van a pasar diferentes líderes que nos van a compartir sus mejores prácticas de talento internacional en el sector. Y es que vamos a conocer de primera mano, a través de estos perfiles profesionales de los más reconocidos, pues qué están haciendo, qué programas utilizan, qué iniciativas, qué estrategias, para que nos inspiren y que nos guíen. Y lo vamos a hacer de una manera dinámica, porque van a ser 7 microponencias de 25 minutos y además van a venir de algunos puntos diferentes de España, de otros países como Canadá, como Francia, también evidentemente de regiones aquí de nuestro territorio. Bien, pues nos vamos a ir en primer lugar a Francia. Vamos a comenzar. We begin with the first of them, Catherine Lilan, Synopsys University Program SARA, who is participating via video call. Ahora la vamos a ver. Catherine's experience focuses on global customer success management, expert in technical support, training, project execution, and team management at LSI Logic, Synopsys, and Texas Instruments in both France and United States. Un aplauso para ella. Adelante.
Good afternoon, everybody. Do you hear me? Can I start? Yes, I can start, or?
Yes, we can hear you.
Okay, perfect. Let me share my screen. Do you see my screen? Yes?
Yes.
Okay, perfect.
It's okay. So thank you very much.
So first, I really want to thank you for organizing this conference, and I would like to apologize. I would have loved to be in Valencia with all of you. Unfortunately, I'm traveling this week, so it was difficult for me to manage this travel. So I will do it only remotely. So let me introduce first myself. So my name is Catherine Leland. Like you introduced myself, I'm working at Synopsys, and I am managing the university program within Synopsys in Europe. Okay, so I'm managing all the collaboration with academia in Europe, so of course with Spain. And what I would like to do today is to share with you how at Synopsys we are partnering with academic institutions to tackle one of the most significant challenges that the semiconductor ecosystem is facing, attracting, train top talent. And this really to answer the semiconductor ecosystem need. We all know that today we've been experiencing a period of major transformation, and that computing has been completely reinvented. New applications are emerging, research across many fields is advancing, but however, as soon as we move forward, we also face significant challenges. The AI and the hyper-connected world generate a vast amount of data that must be analyzed. And what is at the heart of this AI revolution, it is hardware. And hardware is really playing a critical role enabling this innovation and really to support all those new applications. What we see in hardware is that the complexity of new systems exceeds anything we've never seen before. It's really driving, increasing the number of transistors in the device. At the same time, we are entering in the era of Entstrom, where both the design and the manufacturing challenges are growing exponentially. And it's clear that innovation and innovating in Europe is essential to address this trend. So first, I just want to introduce quickly Synopsys, and then we will go down into the main topic, which is the talent and the need of talent. So what we are doing at Synopsys with our customer, and what our customer are requesting to us, is really to work closely to address those complexity and new technology challenge by helping them to raise their productivity. So for that, we have different family of product. We have an IP portfolio that enable design reuse and really helping teams to build their system on proven solution. We have a comprehensive EDA platform on analog, digital, and also photonic IC designs, which are coming from the architecture level down to the tape-out, which really help to automate and really develop a new system. And since a few years, we have introduced also some AI in EDA tools. And we have mainly 3 families of AI in EDA tools to help to raise the productivity of all of us. First, it's an AI-driven solution, which help to automatically do some space exploration to improve all the implementation work. It could be in the digital flow with our Fusion AI tools, which really doing automatically exploration and try to obtain the best PPA. It could be on an analog flow with our ASO.ai, test insertion, how to reduce the insertion of a test structure without impacting the full coverage. Same thing for verification. And the second type of family is, because of the technology going really small, becoming really small, it is important to get out some data from the real silicon, to analyze some data from the real silicon, and to bring back this data within the design phase. And we have a complete family of AI-driven data analysis tool to help us on that. Last but not least, we have, since last year, we have a launch on generative AI tools, which is called Synopsys.ai Copilot, which really help the designer not only to have ask directly questions to our entire technical database, and without having to look for within documentation and all those things. It's help also of sharing knowledge in between teams. I mean, expert can, by putting their knowledge in this database, share their knowledge with the beginners. And also it helps to, in the automatization of the design flow, to create automatic scripts and code. And all those AI tools are really here to help and to improve the productivity. But even with those leading edge technology that can be available not only to the industrial world, but also to the academia world, this is really something important for us at Synopsys. Okay, what is the major challenge that today the semiconductor ecosystem is facing is the lack of talent and the need of people. If we look at the numbers, sorry, I went too fast. One back. If we look at the numbers, I mean, the need of hardware engineer is growing exponentially, and a lot more and faster than what the trend today is. And in parallel, if we look at the number of talents which are coming out from academia, it's growing a little bit, but not as much. So we are missing talent. And what will happen if there is no talent? So I did a little game. I asked ChatGPT, what will happen if there is not enough hardware engineer? So the first thing that he says is that manufacturing disruption. Semiconductor fabs and electronic manufacturing will struggle. It will be difficult. Infrastructure problem, critical system maintenance, innovation slowdown. If there is no one to innovate, to have new idea, to implement their new idea, it will be difficult. That means we will have a big economic impact, and we will have to do some major societal changes. So to continue this game, I asked ChatGPT, so what we should do to prevent this scenario? And what ChatGPT answers is that we need to promote STEM education. We need to create more pathway into the field and to support education. And we need also to improve, of course, working conditions to ensure that we make this ecosystem more attractive to young talent. And this is what, in our program, in the Synopsys Academic and Research Alliance program, which is named also SARA, we are doing by collaborating with academia in order to build a pool of talent that will answer the industrial need, and also to work closely with the researcher in order to ensure we can support their work and innovate in Europe. So our program, Synopsys Academic and Research Alliance program, is really the bridge between academic and industry, and really to build the foundation of the European ecosystem industry. So what is my main pillar in Europe with this program, and what is my main goal and how I address that in Europe? Okay, so my first main pillar is to build educational collaboration, to work closely with a professor in academia and to support their work to build a new education program. The second pillar, which is as much important, it's really to build research collaboration. Okay, because we need to drive innovation. Without idea, without people, nothing will happen. And in order to support me on those two main pillars, collaboration in education and research, we do have our university software program, which is how we make our product available for academia, and our main distributor that most of you may know is Europractice. Okay? And so let's go down now more deeper in the talent and what we need to do to build more talent, and what we, Synopsys, worked out with some European academia institution in order to support to build a talent pool. So the first thing is talent attraction, how we can attract talent. So I did another little game. I asked Google, what is an electronic engineer? And this is what Google gave me as a picture of an electronic engineer. Young people doesn't know what an electronic engineer is. They know what a doctor is. They know what an influencer is. They know what a teacher is, but they don't know what an electronic engineer is. That's why most of the STEM students today, they are going to computer science. They are going to AI. They are going to green technology science type of engineering. They are not coming to hardware. They are not coming to semiconductor. They don't need. They don't know. We need to encourage more students to pursue their career in hardware design. So what are we doing? With the requests, and of course all that is done in collaboration with the professor. It's not us by ourselves, and it's not only us and the professor, it's us and some other industry which are willing to work with us. So it's really a joint collaboration. We are going to university, and we are offering to university diverse program. What we have seen is that the first question is branding of electronics, how to make our ecosystem more attractive to young talent. So we are doing some lecture for that, which explain who we are, what it is to become an electronic engineer, which type of job they can have, which type of career they can have, that our ecosystem is open for everybody, whatever their background is. It's not only for high technical people. It could be for people who are more looking for a kind of communication jobs, that want to have a solid technical background, but want eventually to move to sales, to marketing, or even a support type of engineer. So it's really important to share that with the young talent. So we can, upon request, or in collaboration with academy, deliver those type of lecture. What we have heard also from students is that sometimes the studies are not so funny. So doing some computer science is a lot more practical. You code and then you can see the result. So what we are doing also with some academia is to provide more hands-on activity to make the learning a little bit more engaging and attractive. And for that, and the last point is, in order to build a little bit more the bridge between the student and the industry, there is, of course, the internship, but we have been also supporting and sponsoring more and more summer schools, which are a great tool in order to build the link between the industry and the student. So that's first step, how to attract. I just sharing some idea. Of course, we are always open to new ideas, new needs from different academia if they want us to help them in some other topic. So the second part is we have attract some students. What needs to be done in order to ensure that today's curriculum will answer the industry needs in 3, 5, 9 years? Okay, because it takes time. First, to change the curriculum, it takes time to train the student. So it is really important to have this discussion, the industry and the academia, on what's need to be done to to ensure that the people, when they will get out, they will have the skill that the industry needs. That's why we have a lot of discussion, and we are trying to really give advice, support the academia by helping them on what they need, for them to really understand, okay, what will be the industry needs. For that, we can provide different type of support. Because also developing, it's good to have, okay, I want, for example, let's take the idea of AI. How to introduce Copilot type of, or Gen AI type of technology in class. Okay, we've got a good idea, we want to do that, but now it is difficult also to create new curriculum. It is difficult also to put all that together. So we are doing we can provide some support to academia in order to develop those new curriculum, to develop those new projects. We do have a complete training database, which is available for free to academia, for the student, for the professor, for the researcher, which contain self-paced training, which contain also training which are really framed for the professor to deliver in class, including lecture labs, including virtual PDKs or standard cell library, to ensure we can facilitate a little bit the professor work. Okay, does it make sense that the professor teach on the tools? We don't think so. So let's maybe offer more hands-on project. Let's maybe let the students go through self-paced training, then do some labs or some hands-on project, and the professor focusing more on the really fundamental skills that need to be taught. So that's some example we can work together. So like I already mentioned, hands-on projects is really something which is required more and more, and that more and more universities are asking us to deliver. And we have been helping some university to deploy hackathon, small contest, student project, Olympiads, all sorts of hands-on activity which can really help the student to play and to use the tools and to see what it is, what it means. We are also working more and more on tape-out class to ensure also that maybe students can create their own silicon. They design it, we send it to fab, it's coming back, they can test it. So that's another type of project which can really make the study more enjoyable. Last but not least, like I mentioned, we have sponsored a lot of different summer schools this year, and we strongly believe that summer school it's a great way to showcase the semiconductor industry and also to provide some advanced training on the latest technology. It really gives to the student a direct access to the industry professional, helping them to understand real-world challenges and eventually opportunities. It's really a platform for the student and the industry to connect. So really, our goal there is what can be done to make also study more attractive, enjoyable, whatever word we want to use, in order to attract more students and to train them. When they get out of university, they have a level of skills that the industry is needed. Then as a second pillar, what is also, we believe, strongly important is to do some research collaboration. Why? Because first, research, fundamental research is driving innovation. And if we want in Europe to innovate, we have to collaborate with a research institution to ensure we provide to them the leading edge technology to ensure that they can innovate and they don't have to reinvent the wheel. Okay, what I'm hearing from a lot of academia or researchers I'm working with is that, yes, open source tools are great for bachelor type of level to have the students start to use, to learn. But as soon as we go to a master level, if we want PhD to do real research work, they need to have industrial type of technology tools. So this is something really important. And through our collaboration with academia, the research part is really important, and we really want to make our leading edge technology available to academia. We have a different type of methodology to build such type of collaboration. It could be a complete legal framework in which everything is defined to who belongs the IP with some potential funding inside. What is really important is first to understand, is there a technical match? Is there something that you are doing that we could be interested and that we want to support? Once we have this technical match, we can build around and as much as we can support your work to ensure that you can innovate with the leading edge technology and move forward. And this is really important. We believe that it's really important to build this research collaboration in the European ecosystem. So that's really what I wanted to share. I make it maybe a little bit too fast, but it is important. We strongly believe that we need to work together. We need to work the industry and the academia together, and really in order to build the foundation of the ecosystem and to invest in the future. And this is really my goal as a European university program manager, is to build such type of collaboration and to try to work all together. So I don't know if there is any questions. And
okay, thank you very much, Catherine.